A black hole is a truly fascinating object. It is a region in space where gravity is extremely powerful. Once something crosses a certain boundary called the event horizon, there is no turning back. Black holes are often born from stars, but not just any star can form one. It must be a very massive star, much larger than our own sun. When such a star runs out of fuel, it collapses inwards. This collapse is catastrophic and swift. The star's core implodes under immense gravity, triggering a supernova. What remains of the core continues to shrink, becoming a black hole, a point of infinite density known as a singularity. The defining feature of a black hole is its gravity. This gravity is so incredibly strong that nothing can escape its grasp, not even light. We detect them by their effects on nearby matter and the space that surrounds them. Black holes do more than just trap light. They fundamentally alter the universe around them. They warp the very fabric of space and time. This idea comes from Albert Einstein, whose theory of general relativity changed our view. It showed gravity is not just a force, it is a curvature of space-time caused by mass and energy. Imagine space-time as a flat rubber sheet. If you place a bowling ball on it, the sheet will bend and curve. A black hole does something similar to space-time, but its effect is far more extreme. It creates an incredibly deep dip, often called a gravitational well, from which escape is impossible. The closer you get to a black hole, the steeper this gravitational well becomes. The curvature of space-time grows more intense, affecting how objects move. Light itself bends as it passes near massive objects, an effect called gravitational lensing. This has been observed many times, confirming Einstein's revolutionary ideas. The warping of space-time is not just spatial, it also affects the flow of time. Near a black hole, where gravity is immense, time itself behaves very differently. The slowing of time near a massive object is a phenomenon known as time dilation, specifically gravitational time dilation. The stronger the gravity, the slower time flows. This is not science fiction. It is a real physical effect. Imagine an astronaut orbiting a black hole. They are deep within its gravitational well. For them, time would appear to pass normally. However, if they could see a clock on Earth, far away from the black hole's influence, they would see that Earth clock ticking much faster. This difference is truly mind-bending. If the astronaut spent a few hours orbiting close to the black hole and then returned to Earth, they would find something astonishing. Many years, perhaps even decades, could have passed on our planet while only hours passed for them. They would have effectively traveled into Earth's future. Popular films like explore this. The movie depicts astronauts visiting a planet that orbits a supermassive black hole. Due to the intense gravity there, every hour spent on that planet corresponds to 7 years on Earth. Black holes are regions of extreme gravity, but could they be something more? Could they offer a path to other places, or even other times in the universe? Some theories suggest this might be possible. The idea involves concepts like wormholes. These are also known as Einstein-Rosen bridges. They are theoretical tunnels through space-time. A wormhole, if one could exist and be stable, might connect two very distant points in space. Imagine folding a piece of paper, then poking a pencil through both layers. The pencil creates a shortcut. A wormhole could be a similar shortcut through the vast distances of the cosmos. It might also connect different universes, or perhaps different points in time. However, there are many challenges. Current theories suggest wormholes would be unstable. To keep a wormhole open and traversable, we would likely need something called exotic matter. So, using black holes as portals or as machines for time travel remains firmly in the realm of theory, and perhaps imaginative fiction for now. The idea of traveling back in time is thrilling, but it also raises many difficult questions. These are known as paradoxes. The most famous is the grandfather paradox. Imagine you could travel to the past, and you met your own grandfather as a young man. What if you did something to prevent him from meeting your grandmother? Then your parents would not be born. If your parents were not born, then you would not be born either. But if you were never born, How could you have traveled to the past? How could you have interfered with your grandfather? This creates a logical contradiction, a loop where cause and effect break down. Some scientists believe that if time travel were possible, the laws of physics would prevent paradoxes. Perhaps the timeline is self-correcting. Any attempt to change the past would fail, or it would lead to the same outcome. Others suggest that traveling to the past might create a new parallel timeline, or perhaps travel to the past is simply impossible. Black holes push our knowledge to its limits. Through ongoing space exploration and research, we gather more clues about the cosmos.